Michael Gerakius from Metis
Technologies.
Metis Technologies. We're going to go places I know nothing about today. We'll start with some history. You are Central Coast centric, Central Coast fanatic, Albany International for quite a while. Tell us a bit about that and then we'll get on to the real stuff.
Sure. I moved on the Central Coast when I was 10 years old. My parents were chicken farmers further up the road at Mangrove, but started working with Albany after I finished my chemical engineering degree. And Albany International, which was a large American conglomerate involved in technical textiles, was based here on the Central Coast. And I had the opportunity to explore the world of technical textiles, you might say.
Can I take you into the filtration area? That's where you're going?
Sure, yes.
And
for the last 20 years I've been the product development and general manager and finally global general manager for the filtration division. That was sold in 2008 and since then I joined Metis Technologies. Now, Metis Technologies is a startup company that was started up to take advantage of a new fibre that came to market. This fibre, a polyacrylate by its chemical name, was probably invented about 50 or 60 years ago.
Have you got something you can show us on this?
I always like to bring a little bit for us because everybody gets excited when they see it's pink. It basically is, in its textile staple form, very similar to processing other technical textiles. As a matter of fact, the textile industry hasn't moved very far past when they try to mimic wool, and all they've done is change the consistency of it with different polymers.
Okay, we're back on.
And the excitement of what we have here is that this polymer was invented, I don't know, 20, 30 years ago, but it's never been commercialised. And as time goes by, we found, we believe, a great niche for this fibre. It has a lot of high temperature properties. It'll take over 200 degrees Celsius in terms of fire resistance and heat resistance, but we are interested in its filtration capabilities. Currently, Australia is very much a coal producer and a coal electricity generator. Australia produces, exports about 400 metric tonnes,
and our government wants to become clean
exactly.
coal burners, don't we?
So it's going to be a difficult ask for the government because globally the 40% of the generation of electricity comes from coal. And regardless of how many other greener technologies we put, there's what they call a load base, a standard underlying amount of electricity that's produced from coal. Because of our exposure through Albany filtration and the power generation industry, we saw an easy fit for developing this fibre into the power generation.
So is there intellectual property there in that what
yes.
what I've got here?
Yeah. Originally the acrylate itself, the polyacrylate, is not patented, but what's happened is in time, and there was a patent, worldwide patent in 2010 covering the use of the processing of this material by the use of nanoreagents, in other words making it more pure and more probably accessible for filtration. What we do to textiles and filter bags in the power generation industry is they need to last at least 3 years or 25,000 operating hours. That's a long time. So the purity of the fibre and to be able to be consistent throughout its polymer is very important. What's happened now over the explosion of generation in the developing countries, and in particular China, which was at one point installing the Australian equivalent of generation every 3 months, is that there's been a consumption of the polymer that was in use before called polyphenylene sulfide or PPS. Now that was great, but that fibre can take the temperature, can take the chemical environment, but it has a weakness in terms of its oxidation. In other words, when there's oxygen greater than a certain percentage in the filter bag house, the fibre starts breaking down. That's okay if you're capturing the exhaust of a boiler and making sure no other air gets into it, but it does limit you to 180 degrees or so operating temperature, and you have to be very careful of the oxygen and some other elements that can make it oxidise. Our fibre, or our application of that fibre, has an advantage in that it is not reactive to oxygen, and that I see a great opportunity in, say, just power generation for now, whereas you could increase the amount of oxygen you can put through, which means you can dilute the hot gases come in with air, which then allows you to burn more. And if you burn more and you're making more heat, then obviously, and you would hope, that there's more driving capacity for more power generation. So that's the link. It's going to take us some time to get it all connected, but there's always a starting point.
So Commercialisation Australia has played a role in this as well?
Absolutely. We were successful in Commercialisation Australia giving us a grant, which enabled us to start a business plan and doing some trials. In 12 months we've been very, very busy. We've started from this material, and we have in the field now in a power station in New South Wales a final product. So we had to go through the technical textile steps. There's installed in New South Wales 500,000 of these at 5 metres long, which are replaced every 5 years, and we'd like to make sure that
5 million.
500,000 filter bags.
Right,
half a million filter bags, 5 metres long.
Got it.
Yeah, they're replaced every 4 years or so. This business is global. By no means are we only looking at Australia.
Do the Chinese have this?
They have the more developed technology.
Or they want to create their own? Or
the filter bag side, which is a slightly different form, but it's a needle, what we call a non-woven, a needle punch product. The Chinese market is burgeoning. It's really still growing, and we expect it to grow in power generation industry for at least another, 5 years. Probably, from our opinion, maybe another 5% every year. In terms of our market, we'd like to certainly trial it. A lot of people don't realise that Australia was the first country in the world to filter on an industrial scale the exhaust of a power station from coal. That technology was developed by the then New South Wales Electricity Commission, and my previous employer Albany played a role in that. Then that was leveraged to not only back into the United States, but more importantly it started up the business in South Africa, where from our plant in Gosford many years ago we sent the first bags to be used in South Africa for filtering of coal exhaust. So there's a lot of understanding in that area.
Globally, where is this technology being evolved?
Excellent. That's our focus as well. We don't just look at Australia. If we look at, say, the market that's used for fibres for power generation, that's around about a $50-60 million business per annum. That's including what's going on in China. We expect that to continue to grow with some certain market pushes that have occurred to something like 150 million within about 5 to 7 years. And the thinking is very simple. There's been a demand for, you would have heard recently in the news in South Africa, where they haven't got enough coal-fired capacity to generate electricity, and they've had some blackouts. Well, their government has announced that they will triple the amount of filter bags in service to ensure that the exhaust is there, and are putting in more power stations. The United States, for example, has 1,200 power stations, of which 300 have filtration of the quality we have in Australia. This takes some time to all be replaced, but even 2 years ago...
Massive opportunity. I'm just,
yes,
Michael,
tremendous,
I'm just thinking, where do you go? What's your strategy here?
Well, the strategy is to understand, who are the main players in this. Obviously, we are still only selling the fibre. We go to the 5 largest world producers. We have introduced our fibre to people in England, in Germany, in South Africa, in the United States. Again, it's a very small part of the technical textile industry, and just in that world alone, it would take still, because these bags and filter bags last several years, it will take us at least a year or two to prove our prototypes. But we've got to the stage of prototyping, and we're waiting for our results now. So we're very excited about that. But not only just power generation. If we think the power generation business is huge, there are many other opportunities that are offered to us in terms of filtering for, say, aluminium smelters, which are then a situation where if it gets too hot, you can't use the traditional textiles, and if you use some of the other high temperature ones, we have a significant market advantage. If the power generation industry is worth, say, 1x, we see the other filtration industry worth 5x.
Wow.
And that's more exciting for us, is we found other industrial applications. And we have 2 countries overseas, one in the United States and one in Africa, trialling prototypes for its fire resistance and heat resistance. we see that industrial market maybe even being 10 plus X. So behind all that, apart from just the fibre, we've had developed some IP which we've patented, and the exciting thing for the connection to the Central Coast, apart from us coming from there, is the ability to try to develop that technology. And through our work with Commercialisation Australia and through the various departments that are there, we were looking to in the next maybe 2 years put a research and development small research and development position here in Australia to develop a little bit of IP that we've developed, but looking at other uses. There's certainly an application in military uses, for example, industrial transport. This fibre has probably the lowest toxicity when you burn it of all other polymers that are available. It doesn't burn, it chars. So there's a lot of applications in automotive, for example. That will be chased. It's a big world. We only want a small pie.
I'd go crazy if I'd see the big world. I wouldn't know where to go. It is that small piece of the pie that's the answer.
Well, even with a big pie, I mean, once a friend of mine said, how do you eat an elephant? A mouthful at a time. Yeah. We certainly are looking at that. We're very focused in what we're doing. We're picking a target, even though there's a lot of targets out there. Certainly, my 30 years experience in the technical textile industry helps us weed out. There's a lot of targets we can put it to.
Tell us what you're going to see in the next 12 months.
The next 12 months, we're
going to hold you to this.
Yes, we will actually see. We're actually looking forward to going from prototype to actual to actual product. We expect that to happen before June next year, and then start looking at. See, we figured a way in part of our IPs that we can probably make. There's a pathway from this fibre to carbon filters, and we want to develop that idea that we've had, and that will also then allow us not just to take the dust particles out of the air, but possibly some gas as well.
Okay, wow.
And if we can do a little bit of that. The world's a big oyster. I mean, we are working closely with CSIRO. We are well connected to through the TTNA, through all the other technical fibre producers in Australia. I'm a big proponent of Australian smarts. I'm a big supporter of them.
We look forward to seeing you established truly back on the Central Coast, so you can stop your travelling.
Yes.
And we will watch this space.
Thank you very much.
Thanks, Mike.
Keep an eye on us. Thank you.